Now we will determine the area of this element, and it is centroids. Okay, so now to determine centroid of this number of different areas, okay, here you have one area. Again, here you have a curved shape up to this point, then you have a straight line here, a straight line here. So this area, we have to know the centroid of this area. So how are we going to do it? Using our concept on engineering mechanics. So now let me show you one by one how to determine the centroid of such an area. Okay, for this condition, let me simplify this into, let me divide this and by the concept of divide and rule. So let me divide this and simplify it, then I will sum them up. Okay, now this is a straight line, so let me have this as area 1. This part is a triangle. Now from here up to here, let me have it as area 2. This one, area 2. And here area 3, from here up to here. It's not, so let me call this element here, it is bounded by a curve, a quadratic function. Okay, because this is a function, quadratic function, let me call this one area 3. Now here I have two areas. Okay, this is a straight line, vertical one, so let me divide into two. Okay, this one and this triangle. So the top one, let me call it area 4, and the bottom one, the triangle, it is a straight line here, let me call it area 5. And finally I have one triangle here, so let me call it area 6. This is area 6. So I have 6 areas. Let me determine the centroid of each one by one. Okay, one by one. Here I need to write the function of this curve. Okay, this curve is from section 2. This curve is this one, this one, and we have simplified it into this one. Okay, this is our function, so it is negative 2.5 x squared plus 7.5 x minus 2.5. This is the function. Okay, so let me start with area 1. Area 1, this is a triangle, so the area of this triangle is given by area 1 equals 1/2 times b times h. So here 1/2 times b times h, so b is this one, from here up here is 1/2 times 1 times h is how much? It's 2.5, so it is 2.5/2, that's equal to 1.25. I hope this one is the area. So this is the area of this element. This is unit square. And the centroid of this element, always we are going to measure from our reference. Let's call this one our reference y, and let's be x. Okay, so from axis y we are always going to measure, okay, positive, because all these functions and all these things were derived using this as a reference. So starting from this, we determined the function, so we are going to continue that way. So this is the area of this element and the centroid, and now we are not worried about y bar, and we are only worried about x bar. So from here up to the centroid of this triangle, it is, by our knowledge from mechanics, x bar 1 equals, it is 2/3 times b. This is equal to 2/3 times 1. This is only 2/3. From here it is 2/3 of the b. So this is our centroid for area 1. Now the only maybe complex will be area 2 and area 3. Area 2 and area 3, because it is now bounded by a graph, so we have to do integrations. But this one, they are all uniform areas, so we can simply calculate them by the general formulas. So now let me do this one. Okay, it is like this: area 2 So now here, let me draw the x-axis. Here I have the y-axis. So at 1 meter, I have what? Around here 2.5. Then it goes up. Then it comes down here. What's the distance here? We already said it is how much? Where the moment is going to be 0, it is 2.618. So it is, here it is 2.618. Here it is, x is 1. So this area, the function of this area is bounded by, the top one is y equal to 2.5 x square negative plus 7.5 x minus 2.5, and here at the bottom it is y equal to 0. So if I take a differential area somewhere here, a very small section, and the dimension from here up to here is called dx. The distance from here up to here is this y minus this y. Okay, so this small area is called dA, where this, let me call this one y prime. Okay, let me call this y prime, where y prime equals this y minus this y, the top function minus the bottom function. The bottom function is y equal to 0, and the top function is y equal to this one. So this minus 0 will be itself. So y prime equals negative of 2.5 x square plus 7.5 x minus 2.5. So dA equals this times this one. So it is y prime times dx. Y prime is already this one, so dA equals negative 2.5 x squared plus 7.5 x minus 2.5 times dx. This is dA. So the total area will be equal to, the total area, this is area 2, let me call it area 2, is the integral of dA, where this area is integrated from 1 up to 2.6. 2.618, from 1 up to 2.618. So this is equal to the integral from 1 up to 2.618 negative of 2.5x squared plus 7.5x minus 2.5. all this will be with respect to x. You can do this integral either by hand or simply by using this amazing calculator. Okay, so let me do the definite integral here. Here you see here the integral of, let me substitute the function, negative of 2.5 alpha x squared, then plus 7.5 x minus 2.5. This will be integrated from, let me say, comma, from 1 comma up to 2.618. The value of this area is 3.787571. This is equal to area 2 equals 3.787571, almost like this. This is unit square, okay, whatever it is, unit square. Now let me determine the centroid of this area. You know that x bar 2 times area 2 must be equal to the integral of x prime dA 2. Let me call this one 2. Now x prime is the distance always measured from the y and up to this place. From here up to here, it is what? X prime 2. Okay, x prime 2. You can say it's just x. Okay, it does not matter. So it's x from here up to where I have taken the section. So this x multiplied by dA2, where dA2 is this one. You can see here one, dA2, okay. dA2 is given by this function. So this function times x will be my function. So x prime 2 a2 equals the integral of, this is just x, because from here up to here it's x, x2 equal to x. Okay, x2 is equal to x. So x times dA2, where dA2 is this one. So if I multiply x by this, I will have minus 2.5x cubed plus 7.5x squared minus 2.5x, this with dx, because dA2 equals this dx. This multiplied by x will give me this one. This will be integrated from 1 up to 2.618. Now again, if I do this with my calculator, this is 6.3 something, is equal to 6.30635621, almost like this. So now x bar 2 equals this divided by area 2, where area 2 is already given here. So this divided by this will give me the answer, 6.30635621 divided by area 2 is 3.787571. So it's divided by 3.787571, 1.665. okay, so x2 is equal to 1.665 meter mass. So this is done. The remaining one is the the bottom part, area 3 here is bottom part. Okay, it is bounded by, from the top by y equal to 0, from bottom by y equal to this function. So we will do that one. Okay, so now let me do it. Now let me draw my reference. Here is 1 meter, 2, 3, 2, 3. At 2.618 it crosses. Okay, now it's curved like this. My area here, this one is this one. This one. So this bottom graph, it is what? Y equal to minus 2.5 x squared plus 7.5 x minus 2.5. The top graph is y equal to 0. So if I take a very small differential area here, okay, very small differential area, and its dimension is here dx, its height will be this minus this function minus this function. Okay, so now dA 3 equals height times width. The width is dx, the height will be this function minus this function. So 0 minus this function will give me what? 0 minus this, it will be 2.5x squared minus 7.5x plus 2.5. This must be multiplied by the width dx, by the width dx. Okay, so now dA equals 2.5x squared minus 7.5x plus 2.5. This is what we are going to get. So let me determine the area. Area 3 equals the integral of dA, where dA equals from this is 2.5 x squared minus 7.5x plus 2.5. This is with respect to dx from where? From here it is 2.618 up to this is 3. So this is from 2.618 up to 3. Let me integrate this one using the calculator. So area 3 is found to be this is the area is 0.454237. 0.45423747 unit square. Okay, this is the unit square. So now let me determine the centroid of this area. Again, the distance from this, from my reference up to my differential element is x. So we know that x bar 3 times area 3 must be equal to x times dA. dA is already known, it is this one. dA is this one. This dA multiplied by x will give me 2.5x cubed something. Now let me write here x times dA, it is 2.5x cubed minus 7.5x squared plus 2.5x dx. This will be integrated from 2.618 up to 3 near x bar 3 area 3. Integrate this one using the calculator. Integral of 2.5 alpha x to the power of 3 minus 7.5 alpha x squared plus 2.5 alpha x. This integrate from 2.618 up to 3. This is 1.30635621. Now x bar 3 equals this divided by a3, where a3 equals 0.45 something. So 1.30635621 divided by 0.45423747 is equal to, divided by 0.45423747, 2.876 meter. Okay, this is x bar 3. This is x bar 3. Now let me go to area 4, area 5, and area 6. They are uniform sections, so I can simply determine it by simple observation. Now let's continue with area 4. Area 4 is here, this one. It's simply a rectangular section. So area 4 equals, for a rectangle, it is width times height, or breadth times height. So it is 1 times the height is 2.5. It is 2.5 units square. Okay, the centroid for this one from here measured from the y. Okay, because the centroid is at the center of this section. From here 1 2 3 plus half of this is 3.5. Okay, so x bar 4 equal to 3.5 meter. For area 5, it is a triangle. The area will be 1/2 times base times h. 1/2 times the base is 1, the h is total is 10, this one is 2.5, so the remaining will be 7.5. This will be 3.75 unit square. And x bar 5 equals what? The distance from here 1 2 3, and from here up to this center it is 2/3 of this width. So it is 3 plus 2/3 times 1. This is equal to how much? 9 11/3 is 11/3, and number form 11/3, 3.667. You can write like this, or you can write like this, meter. So for area 6 equal to, it's again a triangle. 1/2 times base times height, it is equal to 1/2. The base is 1, the height is 10, it is then 5 unit square, whatever the unit is. And the centroid x bar 6 equal to the distance from here up to here plus from here up to this centroid is b/3. So the total distance here 2 3 4 up to here is 4 plus from here up to here it is b/3, where b is equal to, the distance from here up to here is 4, then from here up to this center it is b/3. So 4 plus b/3, 4 plus b/3, where b is equal to 1/3. This is 12 13/3 meters. So the location, the centroid of each area is determined like this.